But anyway, all these things are self-consistent. Okay, they are all self-consistent. Now we could go a little bit further. Yes, so I think I could remove all this. And when I give you the connection of the light front coordinates with the incident form coordinates, including that of the metric, I have in my mind to tell you a few calculational simple steps, which are usually not written there in the literature, but they without them it becomes difficult to proceed further, and with them it becomes much easier to proceed further. So there is one of the I will talk about the symmetries, and one of them is this bisymmetry. You see, in the we can have symmetries with respect to the target space or the space time, and we can have symmetries with respect to the worldsheet space. So this is one of the symmetries which is with respect to the worldsheet coordinates sigma and tau. And here H alpha beta, of course it's a function of sigma and tau. It goes at H prime of alpha and beta, sigma and tau, and this is e to the power minus 2 omega sigma and tau, or sigma H alpha beta tau and sigma. This could be e to the power minus 2 omega, could be expanded at 1 minus 2 omega plus into H alpha beta. This could be written as H alpha beta plus delta H alpha beta. Here, this delta H alpha beta is minus 2 omega H alpha beta. So then we have to watch out with respect to the indices being upstairs or downstairs. When it is this, then it is the inverse of that, and this will give you plus now. You see, as usual in all transformations, if you express the transformation in this form, this is called as the finite form of the transformation. Right? This is called as the finite form of the transformation. And this is called as it is the same transformation, but expressed in terms of the infinitesimal quantity. So this is called as infinitesimal transformation. Okay? So you can write, I mean, just like expanding it and collecting the things here. So this is in the infinitesimal form, and one is in the so this is with H alpha, I mean H alpha beta going to H alpha beta plus delta H alpha beta. This would be infinitesimal form. Infinitesimal form of transformation, and H alpha beta going to e to the power minus sigma times, this is called as the finite form of transformation. Okay, this is just two different forms of transformations, this or this. Now in the same go, I wanted to prove one thing, for which I directly jumped onto the word sheet symmetries. It was mainly to prove that T alpha beta was equal to 0. So what was delta S now minus d2 sigma square root of minus x into now this T alpha beta now I put the value of this delta H alpha beta, which is minus 2 omega of sigma H alpha beta into T alpha beta. Fine. I have just put the value of this delta H from the infinitesimal form of transformation that we just wrote down. Okay. And it now let us see that this is non-zero. This is non-zero. According to the variational principle, I should have 0 equal to delta S, and therefore all this ought to vanish, and this is possible only and only if T alpha beta is 0. So only if T alpha beta was 0, right? Okay, and so T alpha beta should therefore be 0. Although we can calculate its components T00, T11, T01, T10. Okay. Or similarly, in the light front, we could calculate T plus plus, T plus minus, T minus minus, T minus minus. Okay, if we write it as a 2 by 2 matrix. Okay. Then, but overall T alpha beta has to be 0, which means each of its components has to be 0. Each of its components will have to be 0. This actually gives rise to the so-called Virasoro constraints. Eugenia wanted to know Virasoro constraints. So when you have all the components of T alpha beta to be 0, they would be some of them would be naturally 0, but some of them may not be 0. There would be some expressions like del minus x mu whole square or del plus x mu whole square, something. Then they are the so-called classical Virasoro constraints, and they actually become very useful because when you consider the mass spectrum, which means you consider the Fourier modes for this x mu as well as for psi mu, and then these components of T alpha beta equated to 0, which give rise to the, without giving mathematical expressions, they give you some conditions, constraints, which are Virasoro constraints. Then they get converted into the Virasoro constraints expressed in terms of the annihilation and creation operators. So they are operators, so you call them quantum Virasoro constraints. Okay. And what happens here? We have some expression for T alpha beta, because all this that we considered so far today was all bosonic string theory. Okay, and we have arrived at certain expression for T alpha beta. We have not yet written down explicitly its various components, which we can do, because once we know its definition, what is T alpha beta, then we can always write down its values, T00, T01, etc., or T plus plus, T plus minus, etc. But they individually need to be, because this is a general proof that here all these things are non-zero. So the only guy that can vanish is T alpha beta. This is the only guy that can vanish. So T alpha beta has to vanish. Okay. And now this is a purely bosonic string theory, but one can arrive at similar conditions on T alpha beta when you have the, if you add the fermionic degrees of freedom into your action, like you would do in the RNS superstrings, then the T alpha beta would pick up additional terms. Not only this, but additional terms. Okay? Which would arise because of the presence of the fermionic coordinates. Okay? Fermionic variable psi of mu. Okay? So, then accordingly, so the Virasoro constants would change at the classical level. At the same time, when you will go to the Fourier modes, expansion of the psi of mu, and we will see here. I had thought I would go all the way up to that today, but perhaps we cannot. So this is one, and similarly, I forgot it. Anyway, you will have Dirac equations, okay? You will have Dirac equations, and then you will have Fourier modes here. This would be Klein-Gordon equation. You will have Fourier modes there. You will decompose this x mu into the annihilation creation operators. Here you will again expand it into the annihilation creation operators. But we would now remember